record on this computer, and now we are going to share screen. There we go. Okay. So today we are going to go over one of my favorite exercises, which is what I affectionately named Blame the Pope. So you can find it under modules by scrolling down and clicking on module 5's Thursday exercise, Blame Pope Gregory the 13th. Now, as a reminder, last time I mentioned, hey, be sure to read up on the if-else statements. That's exactly what was going on over here. So the if-else statements, right? We don't need to demo this because we're doing this in lecture. It's an in-class exercise. Just be sure to upload what you've done, right? Upload it and I'll basically check it off. I'm going to primarily be checking for how to say you attempted it rather than, correctness. Okay. But we'll go through and I'll be helping by, going through and giving you the answers in the outline for each part as we go through. This used to be a homework, and then I found it worked much better as an in-class exercise. So we're going to be covering a lot here, as it says, if-else statements, or the switch statement, but I don't think Python has a switch statement. The modular arithmetic, string indices, and converting strings into integer. So our goal today is to test what we are going to ask the user for a string. And specifically, we're going to be asking them to input a date. And we want to know if it is a valid date on the Gregorian calendar. Now, I'm not going to say calendar because what is a calendar differs from a lot of contexts, whether we're talking about the Gregorian civil calendar, the most widely used civil calendar. Various religions have their own calendars with their own yearly dating systems. Computers don't even bother with trying to figure out what keeping track of the month and day a lot of the time. They just simply use number of seconds since January 1st, 1970, because that makes a lot of sense. But so again, the Gregorian calendar is most widely used civil calendar. It was commissioned by Pope Gregory XIII, who was Pope during the late 1500s. A number of countries didn't use it until the late 1900s, but it took a while, even though it got adopted fairly early on. Even though it was created fairly a while back, it did take a while to get adopted. This is why if you look up George Washington on Wikipedia, okay, that you see a footnote on his birthday. It's like, why would you? I mean, this is not established fact. Oh, it is totally established fact. But contemporaneous records use the old style Julian calendar and Annunciation style of enumerating years, recording his birthday as February 11, 1931. But the British Calendar New Style Act of 1750, implemented in 1752, altered the official British dating method to the Gregorian calendar with the start of the year on January 1st. So those changes resulted in dates being moved forward 11 days and in advance of 1 year between those from January 1st to March 25th. It is a bit of a doozy, but that is why basically that you might, if you're reading contemporary documents about founding fathers and stuff, the dates, you just got to keep in mind what the current calendar is being used. And just because the British passed something doesn't mean the people halfway around the world are going to be using it like universally. Adoption of things is hard. Trying to change stuff is hard. Okay, so but these days it is the Gregorian calendar, and the Julian calendar, it's an improvement on the Julian calendar. And it's made to improve upon the way that leap years are calculated. Because the reason we have leap years, okay, is because we have the Earth rotates upon its axis once a day, right? 24 hours, it takes 24 hours. Now, then there's the yearly rotation of the Earth around the sun. that takes a bit long, you know, and it would be an amazing coincidence if the amount of time that it took the Earth to rotate matched up evenly with, you know, as an even division of the number of, you know, the amount of time it took to rotate around the sun. You know, it took exactly 365 turnings of the Earth to turn once around the sun. Not the way it happens. Takes about a year, is about 365.25 days. Okay. So, yeah, in the Gregorian calendar, each leap year has 366 instead of 365. It's because that, and because if you don't do this, the seasons start to drift until eventually, like, the seasons all get messed up. Like, because that means that, like, seasons will, I forget if it starts later or not. I mean, other calendars do this, Hebrew calendar is lunisolar, which is a completely different system, and they add in a 13th month every so often. Every calendar notices this difference and tries to fix it and tries to accommodate it. Okay, with varying degrees of success, and this one's fairly successful. So the rule is that to offset this whole seasonal drift, we occasionally add an extra year. Okay, or extra day during the year. So we're going to be using the US formatted date. So this is the input we expect. A month / day / year. A valid month is in the range of 1 to 12, right? We're not asking for January, February, or we're asking 1, 2, 3, 4, right? We're not asking for the name of the month. We're asking for the numerical date format. Now, of course, because of course, the months have different numbers of years. Sorry, the months have different number of days, as you remember from your children rhymes and preschool days. September, April, June, and November all have 30 days. All the rest have 31, except for February, right? And February is the topic of it being a leap year. February has 28 days, except during the leap year, where it has 29 days. So let's now get into the thick of it. Leap years are not every 4 years. They are actually a bit more complicated than that. So a year not divisible by 4 is a normal year. So 2022, this is a normal year. 2021 was a normal year. 2020 was on the other hand, was a leap year. A year divisible by 4 is a leap year. Except if the year is divisible by 100, it is not a leap year. So, for instance, the year 1900 was not a leap year because it's divisible by 100, right? Even though it's divisible by 4, if it's divisible by 100 as well, it's not a leap year. Except if it's a year divisible by 400. So 1900, not a leap year, but the year 2000 is a leap year. Which for everybody, and which is why the rule is often simplified to every year divisible by 4 is a leap year, because for everybody born post 1900, that was going to be true for the next 200 years. You know, it's not going to come this having, you know, if you're still around during 2100, which I hope all of us are, right? We're going to have a lot of confusion that day because everybody's going to think it's a leap year, isn't it? No, it's not. So it's any year divisible by 4 is a leap year, unless it's divisible by 100, in case it's not. But if it's divisible by 400, it's been a leap year all along. Now, I also, on purpose, presented this in the least useful organizational way with these except clauses. That does nothing. If you try to translate this directly into a bunch of if-else statements, it's going to be very painful. So you got to rethink the logic for that. But I'm getting ahead of myself here. All right, here's examples. 1644, that's a leap year because 1600 is divisible by 4, and then if we add 44 more to that, which is also divisible by 4, 1644 is all divisible by 4. 1645 is not divisible by 4, so it's just not straight up not a leap year. 1600 is divisible by, as a leap year because it's divisible by 400, but 1700 was not. Okay. So I like this one because the logic for this is kind of mildly messy, and we just don't need to, but no loops are involved, and it's messy enough that it's it's still tricky for people who are experienced with programming, but also easy enough to understand because everybody knows what a leap year is, you know, especially those of you who have a birthday on February 29th. Those poor people only being able to celebrate, advancing their age every 4 years. All right. So the things we're going to need. So with this one, I have provided some hints on how to do this, but we will be going through this to begin with. The first thing is that we are asking for one simple input, and we need to extract, basically as part of this, 3 parts: the month, the day, and the year, right? Without bothering about those slashes. So one of the things we can do is slicing a string in Python. Slicing is, it's one of my favorite things that exists in Python that I wish existed in other languages, which is the ability to just easily slice a collection. Like, for instance, here is a string called my name. And hopefully you've watched the videos on slicing, but if not, here's a small overview, right? And it's the same format where it's up to but does not include, so where it starts at the beginning point but goes up to but does not include the second point. So for here, 0, 1, 2, hold on a second. Yeah, there it is. 0, 1, 2, 3. Okay. So, for instance, we've got the string my name. This one is 0 to 2. So that means that will hold the value my because it goes up to but does not include that space. Name, sorry, 3 to 6 goes grabs index 3, index 4, and index 5, goes up to but does not include index 6. So we get nam. We can also do a shorthand where we leave out the second number in a slice, where it just simply says from this index all the way to the end. Let me zoom in for the people in the back. And then, of course, just having a single number just simply gives you the letter at that index. It's not a slice. Index 2 up to, but not including 3 is essentially just one character. 0, 1, 2, start at 2, go up to, but do not include the n at 3. So it's just simply a space. So slicing a string, also, again, I want to remind you that strings are immutable. Once you create a string, strings do not change. Any operation you do on a string creates a new string that's a copy. So the other thing to remind you is how, now since we're getting a string, how do we convert it to an integer? We just throw the int on it. So when I was doing this, when it was worth 100 points as a homework, and here's where the old criteria, which is that, hey, can you tell me if it's a date? Handling non-leap year stuff and then handling the leap year nonsense. So if you want to learn more about time and time zones, there's this wonderful video I've linked here on Computer File, which talks about how frustrating dealing with time zones are. This should give you a very clear message. Do not write programs that deal with time or trying to track time. People who are cleverer than me, not that it takes much, people who are cleverer than me have tried and have done a poor job of it. So, you know, it's generally better to use something that has been bulletproof tested. Yep, there's a package for time. It's well written. You should use that and stuff. But here we're going to try to manually calculate validate whether something's a leap year or not. Leap year. Okay, so we're going to start by opening up idle. If you need to, you can open up the text. If you don't have idle on your computer for some reason, because you use that as something else at home, right? And then easy way to do is just go to our Runestone course book and then hit the pen over here and open up go to our course, then hit the pen over here, and that's going to bring up the handy dandy scratch pad. So if you don't have idle installed or Python installed on the computer using for whatever reason, you can access that there. Okay. So with idle though, what we have to do is we just simply do new file, and we're going to create the file, and I'm going to go ahead and save this file as documents, and I'm going to call it leap year. Okay. Doesn't really matter what you call it. So our first task, right, in this is to get input from the user. And then the second task, which we're going to do along with that, is that we want to take the input from the user, right? So first is get input. Input is in, yeah. So let's go ahead and we'll assume the input is in form is string in form, and you don't have to copy down these notes. These are to help remind you what to do. Assume input is in format in form of month slash day slash year, where each letter is some single digit number, right? Right. So assume, for the sake of argument, that that users, and we see this a lot of times when we write dates, that when we write down like April, we aren't writing down 4. We a lot of times prepend it with a 0. It becomes 04. Now that doesn't really matter when we're converting strings, but like a lot of people, like for instance, a lot of people will write, so like 01 23 1992, just made up a date out of that, right? They'll prepend the 0, right? Python, when we convert integers, doesn't care, right? So like if I say, hey, x is equal to, convert from 0, 1, and if I ask x what it is, it's going to say 1. It just says, put in as many as 0. Okay, whatever. It's just the prepended zeros don't mean anything to me. Okay. So anyway, we're going to get assume the input is a string in the form of month, day, year. And now finally, for the second step, now that we got that, is if we assume that, split date into month, day, year variables. Okay, makes sense. We're gonna, once we take in, so we're gonna get the input. We're gonna assume that the user's inputting something correct, because if we don't do that, that leads into an entire side discussion of validating input, right? So we're gonna assume that the string is in the form of month slash day slash year. Okay, and so we're going to want to split that variable into month and day and year. Okay. And finally, what we're going to, and just simply to make it a bit easier, I'm going to remind myself what the indexes are by just simply hitting the keys sequentially, so just so I can think about it. So input's fairly straightforward. We're getting inputs fairly straightforward. We're going to use that with get input. Okay. So day is equal to something. And then what we want to do is we want to solve the following. Month is equal to something, day is equal to something, and year is equal to something. And you'll probably want to surround those in int statements just to convert them into an integer at some point. Okay. So this is where, so go ahead and fill this part out. We're going to spend, let's say, to 2:30 at the latest for doing this part. Okay, so about 7 minutes. It's not shouldn't take that long, but if you're unfamiliar with slices, it may give you some issues. I will check in though. I'll be running around the room checking in. So go ahead and get to work on it. Again, if you have trouble with it, I will give you the answer. Everything go with it? No, it's feel free to work with the people next to you. The only thing you're going to do is go out and make it like the outside. I'll point out. Which you can do it right there. But here, here, so I don't have to, so if you don't want to move around that flight, I have to print it in the cat. Anytime you want to do for yourself, it's fine. No, it's not working. Over here and explain. Because I was already on my way down here. All right, yeah, I'm gonna go ahead and go over over the first part and this part. Sorry, this part and this part, and then I'll give you a bit more time to fill out this and this. So to get our date, we just simply input, enter date in month slash dd slash year format, which is more info than we actually need because we wrote this, but whatever. So we just simply do a date. Any kind of statement, any kind of text works here. So now what we want to do is we want to extract the month, the day, and the years. So to get the date, to get the day of the date, what day it occurs on, that's indexes 3 and 4. So we want to start, so that means we have to do a slice to get those two numbers out. That means we want to start at index 3, go up to, but not include index 5. So the slice is from 3 to 5. So date 3:5. And yes, our day is still a string right here, but we'll worry about that in a bit. So that should give you more than enough information to try to figure out how to do your month and your year. So give you a minute or two more to try that. Once we're done getting those, what we can do is we can say month is equal to int month, day is equal to int day, and year is equal to int year to convert them from strings to integers, but we don't have to worry about that until we've extracted all of our strings. So we get out the strings and then we convert them into numbers because numbers are going to be more useful for checking. Because I mean, you could do it with it all being strings, but then I would have to, you'd have to do conversions at some point. Then you have to put quotations anytime you want to write something down. Is annoying. If it has a leading 0, that's fine. We assume that it's going to have a leading, that the month is going to have a leading 0 if it starts at 1, if it's January or February or March. Yeah, I got a DM saying, hey, can you just simply do, instead of doing those 3 lines after, can you simply do this? And the answer is yes, you can totally just do this, but I didn't want an information overload in one, the more you nest, the more complex you make your one-liner, the harder it is to get to read. And since I'm trying to teach as many people as possible, I try to always make my one-liners as simple as possible. Okay. So for month, we start at 0. We need to go up to, but not include 2. That would be date. We start at 0, colon, to say we're doing a slice, and we go up to, but we don't include 2. It's a very common mistake to try to instead, where you understand how slices work, but you're used to using the range function, so you might accidentally put in a comma here. It's not what we want. Python recognizes it. Python wants to see a colon here for this for a slice. Now the last one is actually fairly simple. You could do from starting at 6, go up to, but not include 10, because 10 is technically the last, that's how you get that range. But that feels a bit weird since 10 isn't an index. But that's why I put in the document, you have the shorthand, which is you can leave out that last number and it means going up to the end, but going all the way through the end. So we can now print month, day, year, and I'll just simply show that it works by running it, by saying 0, 1, 23, 1999, and it gives me 00, 23, 1999, right? So I've successfully split it up the way I wanted to. So now that we've got this, we need to figure out how to validate a date. Now, the first thing we want to do is completely ignore leap years, because we only have to worry about leap years in one place, or specifically, there's only one possible day each year. Sorry, there's only one possible month-day combination where it might be a leap year. What's that month-day combination that it might that it's asked that we have to ask if it's a leap year? February 29th. February 29th. That's the only day we care about it being a leap year, because that's the only day that's different on a leap year than anyone else. All the days are otherwise valid on leap years. So otherwise we want to split it up into different ways that we can kind of detect an error based off of, like, is it a valid month? Is it a valid day? The years are pretty much all going to be valid. So all that matters is that is it not going to be a valid month or day? So let's go ahead and do that by grouping up our if statements together, right? We'll write some if statements to group our months together. So what we can do is we can write an if statement to say, hey, if the month is like, I'm going to expand this. So let's see, I wrote down the months over here that say, hey, what the months with 30 with all the months that have 30 days, which are April, June, September, November. So for June is 6, September is 9, November is 11. So if the month is equal to 4, then that means it's a 31-day month, right? Month is equal to 4, or month is equal to 6, right? And so on and so forth. End it with a colon, but we want to put all of the 31-day months here, right? In this block. And what I'm going to do is I'm going to put in the word pass. That is basically the saying that what does pass do? You use it when you've got an if statement or a else statement or any kind of like block of code where you're going to go back and fill it later. This is just basically telling Python, yes, I know I have to complete it, but just skip this block right now. So the pass doesn't really matter in actual code because it's always going to get replaced. Else if, what if it's a 30-day month? month like January, sorry, 31-day month like January. And then we have all the other ones that we want to put in. Or we'll put past there. L if month equals 2 February, the only real exception to the rule, right? So we'll put all the so yeah, 31-day months. No, the date that we don't need to print out 0, the leading 0. 31 or 30-day months. Feb. And when we do it like this level of organization, we get a final, we can just simply put an else here for a print and then do a print invalid month. Because if it's not one of these 3 categories I've set up, then it's invalid month. So what we want, so what I want you to do is fill out the rest of these, right? That might not seem like a task. I'm just going to go ahead and erase this and this. And now I'll make you fill it out because there's a common mistake that gets made here, and I want the student to get the chance to make it so that it can be corrected. All right. So this one shouldn't take nearly as long. I'll give you until 2:40. Let's go with 2:43 to do this, or 2:45 maybe. Sure. So all you're doing is just filling out these conditions. Don't even worry about what goes inside them yet. Right? We're just simply trying to basically organize our code based off of what the month it is. Because our logic depends on first off, it's we've got 12 different valid options for the month. There's got to be one of those 12. And then what the valid days are depends on what the month is. Sorry, I may have missed that. Flip that around. Yeah, I flipped that around. There we go. All right. So what we're gonna do, so the common mistake that a lot I see students make here, or when dealing with long-winded statements over here is statements that make a lot of sense, syntactic, like mentally, but Python doesn't like syntactically because of the way truthiness works. So the common mistake I see here is that, okay, so it's April, June, November, and December. It's April, June, September, and November. They'll do this: 4 or 6 or 9 or 11, which is not what we need, because this says if this evaluates to true or 6, anything that's not a 0 just by itself is true. It's a weird quirk of Python called truthiness. So what we really want is 4 or 6 or 9 or 11 for this. That is the most direct way to do it. However, that does not mean it's the only way to do it. There's actually a few cleaner ways to do this. One way to do that is to make use of lists. Instead, we can do if month in, and then we created a list of all the things in here. 4, 6, 9, say 4, 6, 9, 11. Makes sense? If month is in one of those. Makes the next one a bit easier too, because otherwise we just simply get this very, 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 very long line. Okay, but that doesn't mean the other way was wrong, or even better or worse. It just was. So month is equal to 1, or let's go ahead and do this here, month in. So 1, not 2, because that's taken by February. 3, 4, skip that. 5, 6, skip that. 7, 8, 9, 10, and 12. So now we've got, now double check by eye. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Aren't you happy that your professor knows how to count 1 to 12? All right. Real testament to his intellectual prowess. So anyway, we've got these things. And also because of this, we're able to differentiate or that it's a invalid, whether or not it's a valid month or not. All right, if month is in 4 or 6 or 9 or 11, pass. So again, we're going to ignore the leap year cases, and now we're going to work on 30 or 31 months. So let's work on 30-day months. So if we're inside this block, we need to check if the day is in a valid range. In other words, if the day is, somewhere between 1 and 30 inclusive. Yes. Sorry? You could make a big and statements, but it's so much easier to do a couple ifs. You could do an and statement there. So we just need to make sure, we just need to write a statement that basically says, hey, is our day in the valid range from 1 to 30? So go ahead and work on that. You'll want to replace the path with like something like if, and then we want to create our if statement. And if it's true, then we print valid date. But if it's false, else print invalid day, because the day is wrong. So go ahead and try to fill out an if statement over here. All right. Do people have a solution yet? Or people need more time? Okay. Okay. So if so there's a couple ways to do this. We can always like flip it around, by the way, and like say and check to make sure to see if it's invalid as well. Like we could always flip it around and say, hey, if it's less than 1 or greater than 30, print out that. But I wanted to use this to showcase something that I think is brilliant in Python, and I wish more languages did it, which is you can just simply do it like you would do a normal math statement, which is if 1 is less than or equal to day, which is less than or equal to 30. And believe it or not, that works. Wonderful. Which, by the way, we can just simply copy paste over here and just switch this to 31, and boom, that's both of the non-February conditions done. This makes sense to everybody? Yes. Yeah. For this one, yeah. Yes. Now for February, that's a bit more well, it's not as trickier until we get to the leap year. So what we're going to do here is that we are going to erase that and just simply say, hey, if day is between 1 and 28 for February, it's valid no matter what. But we need to put in a third condition, which is in the middle, which is elif if day is equal to 29. And we're going to leave that blank for a second. Okay, so we've got everything covered but handling the leap year, right? All I did was copy this down and add an elif block right over here. Okay. Copy this down, run an elif block over here. So now we have to approach the thing that we've been avoiding the entire time, which is figuring out whether it's or not it's leap year. So rather than trying to just solve it all right here, because that's going to lead to a lot of really dense statements, a lot of really crooked if-elses, or not crooked, but very deep if-elses and making it hard to read. We're going to go back up to the top for a second. scroll all the way back up to the top, and we're going to write a function to just do one very specific task, which I'm going to call def is leap year, which given a year is going to tell us true or false. Is this given year a leap year? Make sense? That way we can move all the code all that ugly, all that mess of code we're about to write and not have to worry about keeping it indented too much. So given a year, whether something is a leap year. So first off, we can just simply write out, just rule out a bunch of stuff right, at the very beginning. If year if year mod 4 is not equal to 0, turn false. Okay, capital F false. So, sorry. In some languages, it's false is true. True and false are capitalized, and some they're not. So I always mix that up. So what does this mean? If I divide the year by 4, if I ask for the remainder for the year divided by 4, and it's not 0. In other words, if I divide year by 4 and there is a remainder, that's what this comes down to. If I divide the year by 4 and it does not cleanly divide it, then it can't be a leap year because it's not divisible by 4. All leap years have to be divisible by 4. The quality of all leap years, regardless of the other rules. And then I don't have to put an else here because the return false will just simply take care of that. So I can just simply continue on writing over here. So the next thing is, what are those rules again? A year divisible by 4 is a leap year, except when it's not, except when it's divisible by 100, except when it's divisible by 400. So first off, if a year is divisible by 400, it's a leap year, right? There's just no changing that. Right, and so now a plan kind of starts to spring into motion, where the idea here is that if you are able to divide, you can check to see if it's divisible by 400 first, and then you don't have to worry about years that are divisible by 400 after that when you're trying to figure out if it's about years divisible by 100. Or we can take a look at the Wikipedia page again and see that the leap year actually has these extra days occur in each year that is an integer multiple of 4, except your years divisible by evenly divisible by 100, but not by 400. So again, it requires a lot. There's a lot of different correct ways to do this, but to quote one of the people in chat, it's going, no matter which way you choose, it's going to make you feel you not so good at math. So, there are, so go ahead and give it a try, and then I will go over the answer before our class ends, okay? Mm-hmm. return false. You don't need to. Yeah. So the function isn't responsible for printing out the status. That's the function has one job, it's only true or false. Make sense?
I'm not sure. It's like, like not. Yeah, and they last money. On only yes. No, you don't need that. You just need to submit it. I don't have time to deal with all the demos for all for all this. Especially when I plan on, getting all the answers. All right, I'll have 2 more minutes and I'll go over the answer. Scroll down to where? All right, so let's go ahead and finish this off. So if it's not divisible by 4, so if it's not divisible by 4, return false. So the first thing we have to check, so now from here we're, ooh, that was a, all right, if, ouch. If it's divisible, so, all right, now that we've got this, we can assume that's divisible by 4. Okay, so from here on, we can assume that's divisible by 4. So we have to, if we're assuming it's divisible by 4, we have to know under what conditions is it going to be a leap year and what conditions is it not going to be a leap year. All right. So condition number 1 that we have to look at is if year is divisible by 100. Okay. So if year is divisible by 100, that doesn't necessarily mean it's not a leap year, right? It means that it could be a leap year or it might not be a leap year. And what that factor is whether or not it's divisible by 400, right? So if year is divisible by 400, so let me go ahead. Oh, and I forgot to complete the statement. If you're divisible by 100 is equal to 0, if that is true, if it's divisible by 100, and if the year is divisible by 400 is equal to 0, so if it's divisible by both 100 and divisible by 400, that means it's definitely a leap year. Return true. Otherwise, that doesn't matter. Else, if the year is divisible by, else, there is no else. If it's divisible by 100 but not by 400, return false. All right. Now we go back over here. So if it's divisible by 100, great. Sorry, that it might be a leap year, it might not. But if it's not divisible by 100, we have ourselves another else clause, which is very simple. Else, turn true, because if it's divisible, we assume starting here that's divisible by 4, because we just checked if it wasn't divisible by 4. If it is, well, if it's not divisible by 100, we can return true. There are a lot of different ways to organize this. In fact, you can we could in fact do this, with, we could make an and statement instead. But honestly, I prefer to do it this way since you have this over here and that flips from being over here. But this is one way, but this is a way to do that. And we can test it by saying, hey, print is leap year 1999. And then print is leap year 1644. 600, which should be a leap year because it's divisible by 400. And again, you don't have to copy these parts down because I'm just simply testing to see that I didn't make a major logical error. 1900 should not be a leap year, so we should be getting false, true, true, false, I think. False, true, true, false. Excellent. So it means our function's probably working. There could be somehow a case that I'm missing, but I don't think so. So I'm going to comment those out. And now we can simply put here, if the day is equal to 29 and is leap year. Actually, let's go ahead and move this into a separate clause. If is leap year, so I can print out a separate message, that's why. Year. Print valid date. Else print invalid date, not a leap year. All right, and now we can put it through a spin. Or take it through a spin. So here we go. We're gonna say 0404 1247 valid date. Run it, and so let me go over here and start by running it again. 02 29 2022 to be an invalid date, not a leap year, because 2022 is not. Whereas 02 29 2020 gives us a valid date because 2020 was a leap year. All right. So I will go ahead and let's see. Discord, let's go ahead and I'll easily just put it right here. So let's see, what is it? 4 tick marks? Or 3 tick marks and to do some code. In there, and I think there's a way to do syntax highlighting, but I dropped it in Discord if you want to see it. There. And you don't want to go through the entire video to get it. And then because it's a bit too big to drop in the Zoom chat. Otherwise, you can go through the code. Otherwise, it's 3:17. Class is dismissed. I will send out the practice exam again tonight. So remember, the exam is next Thursday. I do not have time for demos today, but I can handle some questions.